Welcome back, guys. Today we will be looking at the mass spectrometer and how we can use it to determine the relative atomic mass of an element. So the mass spectrometer is used to measure the masses of different isotopes of an element along with their relative abundances. The mass spectrometer has 5 basic operations. Here we have a block diagram of the mass spectrometer. So firstly, our sample must be vaporized, so it must be in the vapor state, and then after the sample is vaporized, it is injected onto our mass spectrometer, where we will have ionization occurring. So our sample becomes ionized, so basically we are forming positively charged ions. This occurs when we have an electron gun, which is used to fire high energy electrons at our sample. What this does is that it knocks off one or more of the electrons from the sample, leading to the formation of positively charged ions. After our sample becomes ionized, acceleration occurs, where we have the ions, they become accelerated by an electric field through a negatively charged plate. So what happens is that they start traveling at the same speed, and they travel through the spectrophotometer, where they become deflected. So the next step is deflection. Deflection is when the ions are actually bent, so they are bent by a magnetic field. We can have several possibilities happening. We can have some of the ions deflecting to a large extent, so they are bent a lot, where we have some ions which are deflected the least based on the mass to charge ratio. So the heavier ones will be deflected the least, while the lighter ones will be deflected the most. While there are some ions which have the right mass to charge ratio, they will travel through the spectrophotometer and will arrive at the detector, where they will be detected and recorded, and what we will produce is an output which we call a mass spectrum. We have our mass to charge ratio on our x-axis, and on our y-axis we will have the relative abundance, and what we will get are some peaks in the graph. For example, so on, say our mass is 20, 21, 22 mass to charge ratio, that will be our relative abundances of the different isotopes, and this is what we call our mass spectrum, which shows the relative abundances of the isotopes present in the particular element. Now, what we are using all of this data to calculate is the relative atomic mass, AR, of an element, which is actually the average mass of an atom of an element, which takes into consideration all its isotopes along with the relative abundances of the isotopes. When we calculate the relative atomic mass, we will realize that it is not a whole number, because it is the weighted average of all the isotopes present in the compound. So what we're actually doing is a weighted mean. Let's look at an example. For example, I have this mass spectrum, relative abundance, and my mass to charge ratio. Say I have mass to charge ratio 70, 71, 72, 73, 74, 75, 76. First isotope, relative abundance of say 20.5%. Mass to charge ratio 72, let's say 27.4%. 73, we have 7.8%. 74, we have 36.5%. And 75, we have another 7.8%, not drawn to scale. So percentage abundance should be out of 100, so the total should be 100%. What we will use this data to do is to calculate our relative atomic mass AR. Basically what we are doing is we are multiplying the mass of each isotope by its relative abundance. So that's the first step. Mass 70 multiplied by 20.5 plus 72 times 27.4 plus 73 multiplied by 7.8 plus 74 multiplied by 36.5 plus 75 multiplied by 7.8 divided by 100, since percentage abundance is out of 100%. When we add those, so we will get 1435 plus 1972.8 plus 569.4 plus 2701 plus 585, all divided by 100, and that works out to be 72.632. So if we notice, not a whole number, so what we are having is the weighted average of all the isotopes of this particular element. So the steps again, we have our masses being multiplied by the relative abundances, and we're dividing that by 100 since relative abundance is out of 100%. Let's look at another example. Say you are told that the relative abundance, so chlorine has 2 isotopes, chlorine 35 with relative abundance 75%, chlorine 37 with relative abundance 25%. you need to find the AR. AR is equal to mass of the isotope multiplied by its abundance all divided by 100. That works out to be 35.5. Again, weighted average. If you notice that the relative atomic mass is closer to the isotope with the greatest relative abundance, in this case chlorine 35. Let's look at the previous example. So we had 72.63. This one is a little different from the chlorine 35, but most times what happens is that the relative atomic mass is closer or closest to the isotope with the highest relative abundance. Thanks for watching. Hope you learned something. Remember to like, share, comment, and subscribe.